Hi all, welcome to this new lecture. Here we will discuss about machine learning, its different types and its applications. Okay. So first thing first, what is machine learning? So it defines like this. Machine learning is field of computer science that focuses on learning of machines without being explicitly programmed. It means if machines or our computers can learn by themselves, then that learning field, right, that field of study, generally we call it as a machine learning. Okay, so let's understand this. So if we consider our classical programming, yeah, our conventional programming, so there what we give the rules, right, all the our program, it's basically more about the logic. Okay, and then we pass the data. So we will say, okay, if this condition met, then do this thing, otherwise do this thing, and so on, right? And eventually we will get the answers, right? So for example, if I say, if it is less than 100 rupees, then buy this item, right? Else buy that item, and so on, right? So we have defined that rule, and we will pass what is the price of that particular product, and based on that we will get the answer which product it will buy, right? In contrast, what happens in machine learning, the data and answers are input and the rules is output. Okay, so if you compare with these boxes, so data as well as answers and left hand side, and these rules comes on the right hand side. Okay, so what happens here, so we'll provide the data. Say for example, we provide the images of dog and cat. Okay, we also provide the answers along with that. We'll say, okay, this is the image of dog and this is the image of cat. And then when we pass that thing to as an input to the machine learning algorithms, then machine learning algorithms learn by themselves to identify what are the characteristics of cat and what are the characteristics of dog. Okay, so it comes up with the rules. Okay, so what happens with that, whenever we give now new image, then it will be able to identify which one of that is cat and which one of that is dog. Okay, so I hope now you are able to understand what is the difference between classical programming and machine learning, and why this is different and more powerful. Okay, so now we understand that machine can learn, right? So now next question is, when we can say machines are learning, or is there any way that we can determine whether machine is learning or not? So yes, for that we have this tuple of p, t, and e. Okay, so p is performance, okay, t is a task, and e is experience. Okay, so we will understand by this. So if the performance of the machine or our algorithm, okay, for a given task is getting improved with the experience, then we will say machines are learning. Same with our human beings, right? So if we say we are new to the machine learning, and if we have given the task to write the machine learning algorithms, right, yeah, build the machine learning application, we will maybe not able to do that as a better way at first, right? But with the experiences we will understand, we will learn, and we will grow, right? We will become better at doing that machine learning coding and all. Okay, so same with the machine. So say for example, the task is to classify image whether it is cat or dog. Okay, and if it is able to do that well and well with more and more experiences, then we will say machines are learning. Okay, so that is the metric to check whether machines are learning or not. Okay, so then next question is, what is the experience? As a human we can understand that we have senses, sensory organs, so we get the input, and that input we pass to our brain, right? So that all the inputs that we get from the senses, whether it is from eyes, ears, and so on, right? So that is the experience. But how we can provide such a experience to the machine? So the answer is in the form of data. So what we do, whatever we feed the data to the machines, okay, and that is basically the data of experiences. And as we go on and we provide more and more and more data, and we already define what task needs to be achieved, so we expect that machine should get better and better and better at it, right? And if that is happening, then we will say machines are learning. Okay, so at high level, there are three types of machine learning algorithms. One is supervised, other is unsupervised, and third is reinforcement. So let's understand one by one. So first let's talk about supervised learning. So supervised learning, we provide the data as well as true labels. Okay, so for example, we discuss about the cat and dog image classification, right? So we provide the images as well as we will tell which one of these cat and which one of these is dog. Okay, and we expect that machine learning should learn the rules, and after given a new example, it should be able to predict better, right? So that is supervised learning. So for example, here we want to distinguish what is the shape of the given figure. Okay, so we have this kind of data, along with we have also label, so we know this is hexagon, this is square, and this is triangle, and so on. Okay, so that if we are passing to the our machine learning algorithm and train it, okay, so after that what will happen, it will give us model. Okay, and now so that model means it learns the rules, right? So we gave its data, and we also tell which shape is what, so it learns that, and it build the model. So after that, if I'm giving the new example of square and triangle, right, then our model should be able to recognize that this is square and this is triangle. Okay, so these type of machine learning is basically supervised learning. Okay, why it is supervised? Because we are also providing the label, that's why it is called supervised learning. Okay, and supervised learning also further divided into classification and regression. So only difference is, if we have finite set of outputs, then we call it as classification, and if there are infinite possible outputs, then we call it as a regression. Okay, so for example, if we have same input, say weather data, okay, and if we are just predicting whether it will be an hot or cold day tomorrow, then that is classification. Why? Because we have just two possible outputs, right? But instead, if I want to predict what is tomorrow's temperature, then we have infinite possible outputs, right? Because it's a real numbered value output, it could be anything. So if we have such infinite number of possible outputs, then we call as regression. Okay, so one more time, so if we are providing the data along with its labels or true labels, then we call such a machine learning as a supervised machine learning. Okay, and if we have only few finite possible outputs, then that subcategory of supervised learning we call as classification, and if there are infinite number of possible outputs, then we call as regression. Okay, okay, then next type of machine learning is unsupervised learning. So here we have only data, or we only provide the features, but we don't provide the true labels. Okay, and we expect machines to understand the pattern. Okay, it doesn't know what data it got, but it should divide that data into similar patterns, yeah, or separate that data into different clusters and so on. Okay, so that kind of learning is called unsupervised learning. So for example, okay, we have given some vegetables, and now in this case we are not giving that this is onion, right, this is brinjal, and so on. We just give the data to the machine learning model, and that algorithm should learn the model and should able to identify, okay, all these three things are similar, so it groups into one. Okay, all brinjals are similar, so it should group into one, and same for onion, and so on. Okay, so now it doesn't know that this is brinjal, this is onion, and so on. Okay, but it knows that whatever is here, it's of same kind, and it is different from other kind, and what are the in third group, it's of same kind, and so on. Okay, so such type of machine learning is called as unsupervised learning, right? Because we don't have the true labels, but we give the data, and we want machine learning, or we expect machine learning algorithms to somehow learn and basically separates out dissimilar things, and all the similar things should be grouped into same clusters or same group. Okay, so such kind of machine learning is called unsupervised learning. Okay, and finally, reinforcement learning. So the reinforcement learning is basically based on reward and penalty. Okay, so for example, in the we have new robot, okay, and we have one task, say that it should clear this maze. Okay, so it should start from somewhere, and finally it should come out of that maze. Okay, so if we want to go and build the, say for example, supervised learning algorithm for this, it's gonna be very complex, because for each action of robot there are infinite number of possible output, and that varies with small change in the environment. Okay, so having that logic as a supervised learning or unsupervised learning is not possible at all. So instead what we will do, we just build the agent, yeah, our robot, and we will give that him task. Okay, so saying ki clear this maze, and let it tries its own action. Okay, and if that action is doing good, then we will give it reward. Okay, and if it is done bad action, then we will penalize it. Okay, so now this robot is getting that input and it's doing some actions, and as a output it is giving either positive reward or negative reward, yeah, reward or penalty. So it will understand that what are the good actions, and eventually after doing it hundreds of times, thousands of times or more, it should be become better and passing this maze and so on. Okay, so these type of machine learnings where which basically it's based on the reward and penalty on given actions is called as reinforcement learning, and it is mostly used in the robotics and all. Okay, or say automatic helicopters, autonomous helicopters and so on, because there we can't provide the true labels or what are the actions on each and every state, right? So in that case we'll just let him do the actions and we'll give that reward and penalty, and we hope that with that input it gets better and better. Okay, okay, so this is more about the machine learning. Okay, so what we discussed till now, that machine learning is field of computer science which focuses on learning of machines by itself without being explicitly programmed. Okay, then we said, so there are three major types of machine learning: supervised, unsupervised and reinforcement learning, right? So what is supervised learning? So here along with the data we are also providing the true labels. Okay, so that's why it is called supervised, and it is further divided into classification and regression. If output is finite, then we call it as a classification. If output is say infinite, then we call it as a regression. And if you see, there are different type of applications for each. So as image classification, whether it is cat and dog, so what is that, there are only two possible outputs, so that kind of problem is classification. But instead, say weather forecasting, right, such things we will have infinite number of possible outputs, so such things we call it as a regression, or that goes into the regression kind of machine learning. Okay, the contrast for unsupervised learning, we just provide the data and we don't provide the true labels, or even we don't know what is the true label, and we expect it to basically group them into separate clusters and so on. Okay, so that kind of machine learning is unsupervised learning. It also has its own types. Say for clustering, so when it forms the different clusters, then that we call as clustering algorithms, right? Dimensional reduction we will discuss afterwards, that if there are multiple features, then if it reduces to smaller features so that we can have better visualization, so that kind of algorithms goes into dimensional reduction system and so on. Okay, and finally reinforcement learning. So here we basically focuses more on reward and penalty, right? So robot navigation or game or autonomous helicopters and so on, all those types of application goes to the reinforcement learning. Okay, I'm sure you got convinced कि machines can learn. We can also identify whether machines are learning or not, and we also have all wide range of applications that can be done by machine learning, right? So if we have the data along with the true labels, then we can do supervised learning. Even if we don't have true label, we can do unsupervised learning. And also, even if both are doesn't fit, then we also have reinforcement learning. And if you go with these examples like recommendation systems, right, if you buy on Amazon and then you got the product recommendations, or the customer segmentation, which customer will buy for particular product, right, or especially image recognition, weather forecasting, robots and all. So there are wide range of machine learnings, and in fact machine learning is growing into multiple different fields. Okay, so that's why machine learning is the technology of tomorrow, in fact for today. So we will basically implement it using scikit-learn from next lectures. Okay, so stay tuned. Thank you.